So in lesson 6.5, we're going to solve our rational equations now. So just like we did in our previous lessons, we need to find the LCD. So here we have 3x and we have x. So the greatest number of time 3 occurs is once, and the greatest number of time x occurs is once. So we're going to multiply both of our terms by 3x. So we have 3x times 2 over 3x plus 1 over x times 3x. The 3x cancel out, the x cancels out. Now, what's different is we have an equals to. So if we multiply 3x by both of our terms on the left, we have to multiply 3x by our term on our right. So our denominators cancel, so we're left with 2 plus 1 times 3 would be 3, equaling 10 times 3x would be 30x. So we have 2 plus 3, which would be 5, equaling 30x. To get x by itself, we're going to divide by 30. So x equals 1/6. Since we changed our original problem by multiplying by our LCD, then we have to check to make sure our solution is true. So we're going to have 2 times 3 times 1/6 plus 1 over 1/6. Does this really equal 10? That's our question. So I'm going to have 2 over 3 times 1, which would be 3 over 6, plus 1 over 1/6. And so I am going to make one numerator over one denominator. So I would be looking at having 2 plus 1 over 3/6 and 1/6 are not the same thing. So I can change this, okay? So 3/6 can reduce down to 1/2, okay? So I'm going to have 2 over 1/2 plus 1 over 1/6. And just like we have been doing, is we want to make a common denominator. Or sorry, just like we have been doing, we want to clear out this fraction. So in order to clear out, I'm going to, instead of dividing by 1/2, I'm going to multiply by the reciprocal. So I'm going to have 2 times 2, because the reciprocal of 1/2 is 2, plus 1 times, instead of dividing by 1/6, I'm going to flip it and multiply by the reciprocal, so times 1 times 6 over 1 or 6. So 2 times 2 is 4, plus 1 times 6 is 6, and 4 plus 6 is 10, so therefore my solution holds true. As always, we're going to continue with the same process. We're just going to step it up a little bit. So as you can see, already in my denominator I have x plus 2, but I have this term of 1, and I can turn to a fraction by putting it over 1. So it is missing the common denominator of x plus 2. Okay, so I'm going to have x plus 2 plus 3x over x plus 2, and we can make this x plus 2 over x plus 2, equaling -6 over x plus 2. Okay, so now I have a common denominator. Okay, so, but what did I do? I multiplied this term by x plus 2 to make that common denominator. So if I multiply that term by x plus 2, I must multiply my other terms by x plus 2 in the numerator in order to get to our parts. Okay, so this 1 times x plus 2 is x plus 2. Okay, so we're not going to have the denominator because our whole goal is to clear the denominator. So I'm going to multiply everything by x plus 2, so my numerators and my denominators cancel out. So I have x plus 2 plus 3x equaling -6. Combine like terms, x plus 3x is 4x plus 2 equaling -6. I'm going to minus 2 over 4x will equal -8, divide by 4, x is equal to -2. So again, we changed the equation because we multiplied by the x plus 2. So I need to check it. So I'm going to have 1 plus 3 times negative 2 over negative 2 plus 2. Does that equal negative 6 over negative 2 plus 2? I'd have 1 plus negative 6 over 0 equaling negative 6 over 0. We know we can't divide by 0, so therefore this is a false statement. If it's a false statement, that means that x equaling negative 2 is not a solution because it created a 0 in our denominator. So that's why we always have to check it. So when you're coming and approaching solving rational equations, your goal is to get rid of the denominator. So in order to get rid of the denominator, you have to multiply by every term what is in the denominator in order to cancel numerator over denominator.